Coding standards. This is one that I was not too crazy about when I first came to Tyson, but there was a gentleman that worked with us on MES. His name was Robert Hanachek. He really opened my eyes to what that means. And again, coding standards is not someone trying to impose their will on you and say that you must do things the way that I do things. It's a way of communication again. If we have a standard that says that all private fields will be camel case, meaning the first letter will be lowercase and any subsequent beginning letter of a word will be uppercase, then I can, as I'm perusing the code without seeing the declaration for that particular variable, I will immediately know based on the casing of that variable that that is a private field. Or if I have some standard that prefixes private static variables with an underscore, some other more higher impact, I think, coding standards might be that properties in C# should simply return a value. There should not be long computations within a property. It should simply, if you're going to have to go out and touch your database and do a bunch of other processing, you need to pull that code out and put it into a method, because the method indicates to the consumer of that class or that method that, hey, this is going to take some time to do. It's not simply retrieving a value from a field, you see, but that's communication. And if we start defining coding standards, and I believe that we should define coding standards at a project level, not at a company level, but at a project level. Let's let the team that's going to be building this system or working on this system define the coding standards that's going to help them the most, that's going to work the best for them. And then, but the team has to be willing to adhere to those coding standards, so that as one coder is checking in code, another coder is reading it, they're on the same page. They're communicating through the way they have formatted their code. Does that make sense? It's really another way to overcome some of these obstacles that we hit every day. Another one, and I kind of reluctantly put this one in here, but it's code reviews. I mean, Rob and I have talked a lot about code reviews. We think that they would be a great thing, but neither of us have ever been in a situation where they were executed correctly, or, you know, yeah, anything. We haven't got it done right. One of the things that I see is potentially a problem is that we have a lot of silos as far as knowledge and skill. So you get what basically SMEs on systems, and then they get pigeonholed into that system. They can't move around. Or you got somebody that's really skilled over here that gets pulled out for every special task that there is. And so we don't have this balance of knowledge and of skill sets. And what I believe is that code reviews will serve multiple purposes. One is that it will help increase the quality of our code, because there will be more eyes on the code before it goes into production. We'll be able to identify problems before they get out the door. Again, that will effectively reduce the cost of our code, because we'll catch the problems earlier in the life cycle instead of later. But the other thing that I think is going to be a huge benefit of something like code reviews would be that if you have multiple developers cycling around reviewing each other's code, then not only do those other developers gain knowledge of the other system possibly, or even other aspects of the system that they're working on, but they can also learn new techniques and principles and stuff from other coders. So ideally what would end up happening is, instead of having one coder over here with this knowledge, another one with some other knowledge, another over here with other knowledge, if you mix these guys together in such a way that they're sharing this knowledge, you're ultimately going to raise the level of knowledge among them all, because they can share that knowledge between themselves through these code reviews and things such as that, ultimately raising the overall, the average knowledge of each individual. Does that make sense? I really feel that these are things that we should try to strive for. And I mean, I know I've inundated you guys in the past with stuff like you know, I would come in here writing unit tests using mock objects and throwing in interfaces and model view presenter and everything else, and it's just like, whoa, I've never seen any of this stuff before. But what I wanted to try to achieve today in this presentation is to try to give you more of a clearer picture of how these pieces fit together and why one is good and how they relate to one another and how they kind of complement one another. Does that make sense? And I mean, if I can leave you with anything, I would like to challenge you to think about these things and how can you better apply them or learn more about them. I mean, I know I'm kind of a nutcase in that I'm just passionate about what I do, but I mean, I love it. It's interesting to me. And I always want to learn more, and I wish I could.
Where would you say the bar is right now at Tyson, and what would you say the first step should be, would be?
What would be the first step?
Yeah. Obviously, we can't just start doing everything.
Well, true. You know, I think simple automated testing would go a long way. And I'm not talking about test-driven development. I'm simply talking about let's write some unit tests. Let's design our code in such a way that we can write some unit tests to exercise our code without somebody sitting there in front of it all the time. I think that's going to totally improve the quality of our code. I think, too, if we wrote customer-level acceptance tests such that, hey, when I do this, I expect this to happen, bam. To me, that is a very clear, concise requirements specification right there. That's it.
You're talking about requirements now, not automated tests?
Well, what I'm saying is that if you define this in an automated or in a precondition, action, post-condition type scenario, such that you could then write it in an automatic fashion. But there's two aspects to that. One is that you captured the requirements, what the expectations are for that thing. You've documented your requirements. If you've got a list of, hey, I wanted to do this and 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 this, you know, now that I know what this system is supposed to do, as a coder, I can just look at it and say yes. As an analyst, I can look at it and say yes. Or as a business user, I can look at it and say yes. You know, this is what I want my system to do. Now, obviously, that's at a very high level, and you and I have talked about, well, but if you try to test every scenario that could go through this, you're going to have hundreds and hundreds of tests. You know, we came up with a situation on Scalehouse recently. You know, there's things that the risk of them happening is going to be low. You know, so then I think you need to evaluate, hey, is this scenario really critical or is it not so critical? And let's hit the high points. Let's hit those things that are going to be critical to our systems, invest our time there. If we have time left, then we can start trying an even more comprehensive test. I think another aspect of it would be, and this is actually a principle in test-driven development, is any time you find a bug in your system, you should write a test that exposes that bug. Then once you've exposed that bug through a test, you then go fix that bug, your test passed, and now then you've got insurance that that bug won't be reintroduced into your system in the future. But I really think